Hello and welcome. In this video, we're going to take another look at Matlab vectors. This time around, though, we are going to look at character vectors or one-dimensional array of characters in Matlab. Now, this video assumes that you've been watching some of the earlier videos. We are going to focus specifically on character vectors, not strings in this video. Strings are a relatively new addition to Matlab, and instead what I'm going to do is I'm going to focus on the older approach, which is the character vectors or character values, or a way of representing then a series of characters in a Matlab variable. Now, this assumes a couple of things. I've given you a couple of links here about the matrices and the arrays, but I've also given you a link to the ASCII table, and we're going to take a look at that. But I just encourage you to go ahead and pull this up so that you could follow along with me when we get to some of our examples. But the ASCII table is essentially just a mapping between a decimal value and the glyph or the characters that we are comfortable with, in this case, in not primarily, but not exclusively, but primarily in the English language. In other words, it's a limited character set. We won't be focusing on additional or other character sets. So the ASCII characters then max out then at 126. And you can see then there's a couple of our symbols in there that we commonly use, as well as some unprintable characters, which we won't really get into in this particular video. Instead, what I want to do is I want to focus on how do we actually create a character vector. And we're going to start off with a new variable here that I'm just going to call my first underscore name. And using single quotes, then I'm going to go ahead and put in my first name being Gregory. Now, we're going to go ahead and just highlight this and then put this into the workspace. You'll see that we have a 1x7 vector of characters. And this is, again, a new data type for us. And this is partially the motivation behind this video, is to see that there can be vectors of different data types. In an earlier video, we looked at the logicals. Well, here's another example. Then you can actually have a vector of characters. And the good news is there's not a much different to learn here. And so we could start off by saying first name, parentheses 1. And I think you can probably guess that that is, in fact, going to get my first letter of my first name. So in this case, then that is going to be the letter G. And you also notice that, unlike the numeric examples, that we have the single quotes around the letter G. And again, that's to indicate that this is a character, not a numeric value or anything along those lines. And then so if we want to get the second letter of my first name, well, that's just going to be first name, parentheses 2. And that is going to get the lowercase r. And then we can do things like first name, parentheses end, which would get the last letter in my name, regardless of how long it is. In this case, it's going to be Y, and that is going to be the last character in the vector. So the good news is, again, there's not really a whole lot that we have to learn here. There is, however, some cool tricks that we can play. Just like with the other vectors, we can do things like, for instance, we can shorten my name, and we can just go from 1 to 4. And you'll see here that I'm using the shorthand notation, and that just gets an abbreviation of my name. You're probably going to want to stick with the longhand notation, 1:1:4, at least until you're familiar with using Matlab. And in both cases, then it's going to represent the first 4 characters of my name. All right. And then so the last little trick that we would like to employ here is then the conversion of these characters into their numeric equivalents. And so that's where the ASCII table comes into play. Now, we can use a variety of data types here to force this conversion. The one that we're going to start off with is the conversion to double. And what we can do is we can convert then the entire first name vector into a vector of doubles. And what we'll do here is to indicate this. This will be first name as double. And if we run this particular one, you'll see that I now have a 1x7 vector of doubles. And you're probably wondering, where in the world do these values come from? Well, again, what I want to do is I want to bring back here the ASCII table. And specifically what I want to do is I want to scroll down to the letters in my name. And so you'll see here that for the capital G, that you would expect to get a value of 71. If you scroll down a little further, you get the lowercase r and 114. And again, I can just simply bounce back and forth here between the two. And you'll see that sure enough, if you look here, 71 is the first letter in my name. 114 is the lowercase r. And 101, well, let's just see if this makes sense. If we go back over to the ASCII table here, you'll see that 101 is in fact lowercase e in my name. And then we can go through the rest of the letters in my name. And I encourage you to play around with this a little bit, perhaps use your own name, prove to yourself that you can understand the mapping between the letters and the ASCII value. But I want to play a couple of more games here with this before we leave this topic. I want to demonstrate that you can also convert it not into a double, but we can use another data type called uint8, and we will simply use the conversion here. So for uint8 of our first name, and again, what you get here is just simply a different data type. In this case, it's going to be a 1/7 of uint8. And you probably have a number of questions now. In other words, why did I pick uint8? Well, uint8 because it is an 8-bit unsigned integer, allows for us to have values from 0 to 255. And well, why would we care about that? Well, it turns out we don't need values above that. In other words, since the ASCII values are in fact limited to the values here, if we go back to the table one more time, up to 126, essentially, we don't need another data type to represent all of the potential ASCII values. And again, we'll play around with data types in later videos, so don't worry if this doesn't make too much sense to you. But fundamentally, Matlab has the ability to convert between various different data types. The last little trick that I want to play with this particular example is I want to do something really strange in that I want to take my first name, and I'm going to add 1 to it. And in common practice or in real world, that doesn't make a whole lot of sense. In other words, if you took your first name and you added 1 to it, you probably wouldn't know what to expect to get. However, though, now with understanding a little bit about the ASCII values, you'll see that I get a new vector here starting with 72. And well, if you were following along, you remember that the capital letter G in my name is 71, or rather the ASCII value for it is 71. Well, what's happening behind the scenes is you're simply adding 1 to each of the values in the vector, essentially 1 by 1, and you're adding 1 to each of the ASCII values. So in other words, 71 plus 1 is 72, 114 plus 1 is 115, and so on. There's a couple of different topics that we can pull from this, but what we'd like to do is, just for the fun of it, we're going to use the char function, which allows for us to now force this from a double back to a character vector. In other words, basically at this point, we're going to take these numeric values, we're going to use the ASCII table to turn around and get the characters that correspond to those values. And again, I'm going to run this, and that is just nonsense. In other words, basically what it's doing is it's just taken each of the letters in my name, added 1 to them, and then converted them back to the character. So my capital G turned into my capital H, my lowercase r turned into the lowercase s, and you can see that each of these letters in this nonsense result essentially corresponds to a 1 character shift forward in the ASCII table. We can play around with this. We can now implement things like our ROT13 cipher and some basics of some encryption, which we'll cover in later videos. But fundamentally, the two things that you want to walk away with from this video are, number one, that you can have character vectors and that they fundamentally behave similar to the numeric vectors and how you can access the individual elements. And then secondly, that there is a relationship between a character and its integer equivalent, and you can sort of bounce back and forth between the two, depending on what you hope to accomplish. So as Always, if you have any questions, comments, or concerns, don't hesitate to reach out to me. And hopefully you found this video useful. And thank you for watching.